Hello and welcome to MySecurityTV. My name's Chris Cubbage. I'm the Executive Editor with MySecurity Media, and welcome to our Tech and Sec weekly episode. This is our Tuesday afternoon episode, and today we're going to be focused on machine learning and artificial intelligence. I've got Omid Ejtemai, who's the CEO with PeakHour Urban Technologies, and they're going to be using AI with the Victorian Department of Transport and predicting traffic congestion with their benchmark of predicting traffic congestion within 3 hours. Now, our next guest, Omid, I do hope I'm saying your name correctly, Ejtemai, and bring you on now, the CEO with PeakHour Urban Technologies. Omid, thanks for joining us.
Good afternoon, and thank you for having me.
Very good. You just caught the second half of that interview. Did much of that ring bells with you in terms of the application, trying to stay on track with machine learning and AI?
Sorry.
Can you hear me okay?
I had muted you. Sorry, I thought I should be on mute, so please
okay.
repeat the question.
All good. Well, firstly, thank you very much for joining us. Let's start again.
Thank you for having me.
Good on you. You might have caught the second half of that interview. We were just talking about the application of machine learning in a domestic environment for protection of the elderly. One of my last questions there was, how do they stay on track? Because there's so many different applications of this technology. Maybe introduce us to PeakHour Urban Technologies and how you're applying artificial intelligence. And your gambit is you're going to be predicting traffic congestion within 3 hours of it potentially occurring. So over to you to introduce us to PeakHour Urban Technologies.
Thank you very much again, and thank you for having me. I could relate very much to what your previous guest said, that machine learning, it's such a broad spectrum of technologies, and machine learning is one of them. Certainly, we are using machine learning for predicting traffic, and we believe that the technology is mature enough now, and not just the technology, that the depth of data, available data, is such that we can actually build these platforms to predict traffic. So a little bit background about PeakHour technology, and actually why the idea. Urbanization is real, everyone knows that, and cities are becoming larger. There is an unstoppable migration of people from rural area into cities. We all know that, we all feel that, and because of that, the cities are growing, and obviously mobility and transport is a big aspect of it. In the past, the response has been to build more roads, but that is a very expensive exercise, but also, more importantly, we're running out of space in big cities. So we don't have space for building new roads. So technology is the only solution there that can help. And in the past, to help with these situations, the organization have created traffic models because data wasn't available to the extent that it is today. And the innovation that we are doing here at PeakHour is to utilize data and build machine learning algorithm with which we can very accurately predict traffic. And that is significant because unless we predict, we are reacting. In order to proactively deal with traffic situation and be able to optimize it, we need to be able to predict. And that's what we have done. That's our starting point with the platform that we have created.
Well, I'm reading the release here. University of Melbourne's Australian Integrated Multimodal Ecosystem, or AIMS, brought together PeakHour Urban Technologies, the Victorian Department of Transport and Telstra to create a large-scale AI application hosted on AWS and can predict traffic conditions across Melbourne. As we just learned, it's the data points, really, the sensors that you might be using, and obviously with Telstra in there might be some mobile networks and other related traffic. What's your data points? What's your sensor network looking like? Because most cities now have vehicle counting, there's CCTV across the road network too. Yeah, what's your sensors and the analytics that you'd be using?
Yeah, currently we are using we are ingesting speed data, and actually part of the partnership that we create is also with TomTom. So we
Right.
are reading TomTom speed data on minute-by-minute basis, but also we are ingesting count data. We are looking in Australia and in Melbourne, of course, that we have a system called SCATS. So at intersection, that is the technology that is being used to calculate the signal timing that is adaptive and adjust to the traffic. But part of that, they are also loop detectors. And based on the partnership that we built as part of AIMS, you mentioned, with Department of Transport, we got access to the live data. So we are ingesting also every 5 minute data that is coming directly real time from DOT servers. We are ingesting that, and combined with speed data, we are analyzing the data real time on the fly, and that is our IP to have machine learning components that are custom designed for traffic and making sense of that data. Because data obviously, is important that we analyze it, but we also need to understand the nature of the data and what we are looking for, so that we can understand the patterns and be able to predict the patterns that are short-term in future. So that's what we are doing, but that's just the beginning. There are other sources of data that we like to be able to work with. We are experimenting in our research lab. For example, I'll give you just one example, weather information and how weather actually influences traffic. And there are cities that it influences in a significant way. For example, if it rains or it snows, and there are cities that we see that impact to a lesser degree. So we are very interested in different types of data. We're experimenting that, and that is just a beginning.
How are you managing all this is getting crunched in an AWS environment, is it? How are you controlling the cost of the processing? Because, it'd be like traffic management systems. You almost move into a high HPC environment where, you're using, particularly when you're talking about weather systems as well, that's high performance computing. There's a bit of a cost management here. So there was that. And then before I let you go is the user interface, how you present that data to a user. I imagine you're in the operations center, traffic operations center. That's really where they wanted to know this is at. Or is it on a user app, which will tell the driver, hey, you're moving in and we want to redirect you. So firstly, how are you managing costs on the processing? And then the second, we'll talk about the user interface and who is this for?
Yeah. So when we speak about cost, of course, we also need to speak about value. So as long as that ratio is right. So AWS actually is providing a very cost-effective environment for these type of solutions. Cloud is perfect. It gives us the scalability that we need. It gives us the security that we need, and the computing power that is adjustable and grows with the need. So it's actually perfect for us and for this type of solution. And as I said, compared to the value, I believe is very, very cost effective, and we are very happy to have this partnership with AWS. In terms of how this data is how the result is being used, we have, of course, an application ourselves that we use to demonstrate the results and make it available and visualize. Basically, it's a map-based application that to visualize the results and predictions and the potential congestions in say up to 3-hour horizon. However, we don't expect that everyone is going to use our application. We have developed an API based on open standards that we would offer, and we are offering to organization, to any third party who likes to implement and take advantage of that data, and potentially also app that could be disseminate information to end users. So one of the potential application of the system is travel time information that is based on prediction, not based on the current travel time, but also based on...
So it changes and adjusts itself based on real-time data.
Exactly, based on real-time data and also predicted data. So if there is a journey of 2 hours, if we can work with predicted times, it's going to be the calculated travel time, and ultimately routing could be much more accurate. So there are a number of applications that are conceivable that we can create based on these predictions.
And I take it this is where the AI plays. It's not just machine learning of what that traffic behaviour is and then predicting it, but there's an AI, because if you reroute, then that changes the prediction, right? So there's an ongoing... Is this just learning? Are you just letting it go and seeing that this will learn on its own? Because again, it becomes so complex, you're going to need an AI to be able to do it. And then how do you control it? And how do you know it's right? So there's a few questions there, I'm sorry, but you know what I'm talking about?
Absolutely, and you said it. That's a key point. That's the key point, and I'm just concurring with you because that's exactly what it is. The system learns by itself. And what is also very important in that aspect, you mentioned earlier the point that is really key, and that's cost. And a system that doesn't adjust automatically and doesn't learn becomes an additional cost, because it constantly needs to be maintained and recalibrate and readjust it. And this system that we have created and is based on machine learning and AI, it learns by itself. So it self-learns and it adjusts to new traffic patterns. So for example, in Melbourne, we are in lockdown, and the traffic pattern this week is much different than the
I can even predict it this week.
Exactly. And so the system adjusts itself and learns, and we see that on the fly it adjusts, and the predictions are, again, the accuracy of them are maintained.
That's an interesting one. How do you tell an AI that, don't worry about it this week, unfortunately we're in a lockdown? How does it know that? Because that's quite foreign, in terms of just general traffic flow. For traffic to stop across a city, we've never seen it in our lifetime before, and it's actually happening. Doesn't that throw it off slightly? Like how? Well, maybe back to the question of how long do you anticipate the system to work? Is it going to take a sort of a 365 days of data to understand what that next day might be compared to last year, compared to yesterday? Are you inputting other sort of calendar? You talked about the weather. How much input is put into this, or is it simply learn on the fly and it will learn, or you need to train it to a degree, right?
Yeah, we have done this exercise a number of times. So right now, when we start our database or our system with a blank database, within a day, we see actually reasonable predictions. And within a week, we get to a point that is really accurate, the accuracy that we need. So I'm very happy with that result.
Do you have a set of data already? Like, does the traffic systems and your partners already have traffic data that it's uploaded to? It's not just starting from scratch, or is working with data sets already?
Yeah, we can. There is historical data, and we can work with historical data. But again, we could also start with the basically blank database, and as real-time data comes in within a day, it starts to predict really with good accuracy, reasonable accuracy, and within a week we are basically up to a level that the accuracy is really, really good. So in terms of training, it's really 1 week, all we need, which is fairly fast for this type of application. And your other question, sorry, you had another question.
was more that backup data and then how you apply that and how long it would take. But you've kind of answered that you only need up to a
Oh,
week.
sorry, I remembered your question. So in terms of adjusting to new patterns, if the if the shift is sudden, obviously it could become an issue if there is a sudden change in traffic pattern. But if it's rather slow, which we call drifting, we adjust very well to it.
Yeah. And
But
is it
sudden
speed?
changes in traffic is.
Is it vehicle speed that you think is the key here, where it's monitoring the speed? Because you think about the sort of the Google apps where they're monitoring where their phones are, so you kind of get the red zone on your traffic, knowing that there's a whole bunch of phones all congested there. How much difference is it, say, from the Google app, which is sort of phone based and network based, versus actual vehicles and speed orientated?
Yeah, I would say the speed information that we get from TomTom is also phone based.
Yeah, right.
So the data is coming from that source, but we augment it obviously with flow information and with volume information. So our predictions are combined based on both information. I think that is the key to have
Yeah.
the kind of accuracy.
Okay. Well, let's maybe just finish off as we can with PeakHour Urban Technologies. And I noticed you're in crowd management too. Had a look at your website. Maybe talk us to that, because that'll be our audience ears will prick up if they hear about crowd management in the security context.
Yeah, look, crowd management is quite important in many aspects, especially if it gets to a level, especially for example, the social distancing now
Yeah.
with COVID in crowded areas such as airports or train station, metro station. So what we do, which is innovative and groundbreaking, is we combine known data, for example, train schedules or metro, and we combine that with information that comes based on image processing in cameras, and in real time we can predict crowd densities. So we don't predict crowd movement because obviously it's very difficult to exactly predict the trajectory of people. But crowd density we do with also good accuracy. That is important, that we can basically create create alerts for those who need to know. If we predict, for example, that the density within a train station or metro station or airport goes above a certain threshold that is considered safe for that environment. And that's what we do, and that's fairly new, the technology, which is also, again, based on AI.
And do you have partners in that, or is that something you're just applying the very similar AI but to a different system, transport system or the like? And the other question is, can you simulate it? Can you feed in different data? Because I'm thinking in a security context, we'll often think about crowds, crowd movement, density in risk assessments as well. How much do you think you can play around with this?
Yeah, so we do have a simulation tool, which is an offline simulation tool, which we can use for planning.
Yeah.
We also have built an interface to a VR system, virtual reality system, where you can go in and actually also for training purposes, you can create obstacles, you can define the space and play different things or different scenarios. So that's a planning offline tool that we can use. In real time, I would say is fairly difficult to predict exact trajectory and simulate. And I don't believe that people, in many cases, is necessary. It's the density that is important from a safety perspective.
Nice. And PeakHour, what's your pedigree? How long have you been around? And you're based in Melbourne, I'm assuming?
Correct. We are.
Yep.
head office in Melbourne. Yeah, we are a startup, I would say. So we've been around for about a year,
Oh, wow.
and we have a rather small but talented team, and all technical and focus on innovation and create new technology. So we is a multidisciplinary approach that we have. So we have experts in machine learning, experts in traffic and traffic engineering, but also experts in software development. So we bring all these people together, and we have been able to create these platforms.
Have you got some seed funding to kick it off the ground?
It's all self-funded so far.
Okay, well, you're the CEO, so Omid, it's been a pleasure to meet you, and it sounds a very interesting startup. It's great to see another startup out of Melbourne in this particular field, so it's definitely one to watch. What's the business model then? What's the strategy? You obviously need a sort of proof of concept here in Melbourne, and then you want to be able to scale that or sort of license it out as an API elsewhere.
Absolutely. So we that was a proof of concept, and we wanted to demonstrate that these solutions are real and they actually work and produce results. We are working with cities, and we like to work with cities. We believe our technology can help cities. Again, if we predict, we can also optimize, and we're also working on optimization technologies, and we can help cities become livable and sustainable, reduce emission, reduce congestion. So that's our business model, to work with cities, but also with, for example, private operators, toll road operators. So we are talking with them, and there's quite a bit of interest.
Yeah, absolutely. It was very interesting technology, and I work a lot with cities, so I might be in touch offline, and we'll see what we can come up with. Particularly, I always like the VR aspect, and the simulation exercises will be interesting. So look, am I saying your surname correctly, Ejtemai?
Ejtemai, yeah, but that's a mouthful. So
Ejtemai.
Omid is fine. Most people know me by Omid.
Okay. Omid, thank you so much, the Chief Executive Officer for PeakHour Urban Technologies there in Melbourne. Absolute pleasure as our second guest on our machine learning and artificial intelligence episode. Thank you very much. I'll let you go and put you backstage. And the story link is on our Smart Cities channel as well. So thank you, Omid. Have a great day.
It was a pleasure. Thank you very much for having me.
And best of luck for Melbourne to get out of this lockdown sooner rather than later. It's not looking good.
Sure.
Cheers, Omid. All the best. Thank you.
Bye-bye.